तो आज हम फ्री बॉडी डायग्राम के बारे में पढ़ेंगे। टुडे वी विल स्टडी अबाउट फ्री बॉडी डायग्राम। सो फ्री बॉडी डायग्राम, in short it is called as FBD, free body diagram. So here the concept is, if let us take this is a body block is kept on this surface, right? So here on this body few forces are being applied, right? So we'll try to find which forces are being applied on this body and which forces are being applied by this body, right? So all these forces we will try to find out. So in free body diagram we draw only those forces which are acted on the body and not by the body. तो हम लोग यहाँ पे जैसे ये यहाँ पे मैं एक केस ले रहा हूँ. Here I am taking one example. Here this block is kept on this ground surface, right? Block has mass m. So here I am drawing free body diagram. So here this block is m. Here this is ground, right? So here what will happen? Here the earth will try to attract this body with gravitational force, right? So on this body here in this direction toward earth, toward ground only, here this is mg force. This is force due to gravitational force, right? Due to gravitation, mg. So this earth is trying to attract this block जिसका mass m है, right, with the force mg, right? Now here the earth, since this gravitational force, this is action and reaction force, right? So here every force in the nature exists in a pair only, right? So then what will happen? This block will try to attract this ground with the same amount of force m into g, right? So now another, here we have to take into consideration of all contact forces. So here let us discuss about contact force. So we have to study four kind of contact force. First is normal reaction. So in this video I will try to cover this normal reaction force. It is also called as normal force, normal reaction or normal force. So here see, taking the same example, block mass m, it is kept on this earth, on this surface. So now here see, here there is a contact, here there is a contact between two surfaces. One is, this is ground and here this is block. So here there is a contact between this ground surface and block. So here the block will try to press the ground, right? And again this force, normal force, is a action and reaction force. So here Newton's third law of motion will apply here. So here what will happen? This block will try to push the ground. So here now I am drawing free body diagram. So here this block will try to push this ground with this normal force n. I am denoting this normal force by n. Now the ground will also apply same amount of force. So the ground will apply this normal force to the block, right? So now if I have to draw free body diagram of this block, so how I will draw? Here see, here mass m, right? Here on this block earth is applying one force, gravitational force. So this is mg. Now here see, here this is the force, this is the normal reaction that ground is applying on this block, right? So in case of free body diagram, we draw only those forces which are acting on the body, right? So here on this body, this block mass m, one is gravitational force mg, that is being applied by the earth, and another is this normal force n, which is applied by this ground surface, right? So here this is the free body diagram of this block. Okay, now let us take another example. Here I am taking two block. This is a two block system. So this is the single block system. This is the single block. Now this is two block system. So here let us take mass m1, mass m2. This is a ground surface, right? So now I have to draw free body diagram. So this is block this is block m1, block m2, this is ground surface, right? Now so this is the first contact, right? Contact between m1 and m2 mass. So here m1 will try to press this m2. So here this there will be a normal reaction. This I am writing as n12, right? Now this m2 block will apply same amount of normal force to m1, right? So like this is again n12, action reaction force, right? Now on this block m1, earth will try to attract this with the help of force m1g. Similarly, now this block m2, here again earth will try to attract this with m2g, right? This is so clear. Now here there is a contact between block 2 and this ground surface, right? So now block 2 will apply normal force n2g between block 2 and ground. Similarly here this ground will again apply same amount of force in opposite direction. So this is n2g, right? So now I am drawing more clear here. This is m1. So here this is m1g. This is force due to earth, right? By earth, huh? Then this is normal reaction n12. Similarly this is block m2, and here we have m2g. Then this way only, this is n12, right? And here n2g. So these are the forces that are being applied on this block. So here again on this ground, if I have to draw the free body diagram of this ground also, although not needed. So here like this will be n2g, and here both m1g and m2g, because these are the gravitational forces. These are the forces applied by this block m1 and m2. So this is the free body diagram in case of two block system. So first is single block, now this is two block system, right? Now third case. So third case is in case of cylinder, a sphere or circle, or let me write like this: in case of cylindrical, spherical or circular shape, the normal force passes through the center. Now see here I am drawing, this is surface, here only I have this ring, right? So here see, here this will be normal force, right? So this normal force will pass through the center, and here again there will be a force mg if ring has mass m, right? Another case like this, this is a surface v shaped. Now here I am keeping one sphere, na? Or ring, it's rings you say. So again here this is the center of this ring, so normal will be like this. This will be let us take, this is surface 1, this is surface 2, so this will be normal due to surface 1 normal force. Again this is common normal, na? Like this. So this will be normal force due to this surface 2, and here like this, this will be mg, mass into gravitation force. So we can resolve this, na? Like if this angle is given as theta, let's say here two force, this is n1, this is n2, here is mg, so we can resolve this force, right? This is n2, so angle we can find, then we can resolve this force. This too we can do, huh? So here the important thing is, in case of cylindrical, spherical or circular shape, na, the normal force passes through the center of that sphere or cylinder or whatever. Another case. So this is something like, here this is sphere, there is a contact here, huh? Or let me draw this. Like this, huh? This is surface. Now I have to draw free body diagram. I have to draw the free body diagram of this sphere, huh? Or ring. It has mass m, right? So here, due to this surface is 1, here surface number 2. So here first force will be mg. This is mg, right? Now another force will be like this, normal, this only, huh? It will pass through the center, so this is n1. Now here there is another contact, na, here. So again here there will be another normal force like this. This is n2, and here important thing is this n2 will pass through the center only, right? So again we can make here resolution of these two forces, and we can balance this with mg, right? So this is example, all examples related to normal force, right? And I have drawn free body diagram. So in next video I will draw free body diagram in case of tension, that is tension in a string, right? So that is again very important. So I hope this is clear, huh? Please watch this, and yeah, thank you so much.